Hi, and welcome back to the Low Level Devil Channel's OS development using the Linux kernel series. If you haven't seen the first video yet, check the details section. I'll put a link to it in there. In the previous video, we set up our initial file system and boot process, copied the pre-built kernel from our host system, and wrote some code to use system calls to communicate with the Linux kernel. In this video, I want to start by reorganizing the project and creating a shared library to hold our common functions so that we can import it into other executables that we can create later. So let's get started. Okay, first I'm going to start by creating some folders here. So we'll create an include directory. Let's see, move this. We'll create one for our Init, which is our main program, and create another one for a library. We'll call it mylib. Okay, so now let's take these files and we're going to move them into our Init. Let's see. There we go. And we can remove this file that's no longer needed. Okay, so now we'll start by creating a base makefile. So this is going to be the base for our makefile for all of our internal projects. Start with the shell function. This is for building the project on the host system. So we set up our compiler here, some flags for the compiler. We want the no stdlib so we don't include the C runtime. And we're also gonna put this include directory in there so it's included by default. Path to myos, and we're using this question mark equals so these values can be overridden in the submake files if we decide we need to. Alright, we have our LD flags. Actually, you know what, I don't think we're going to need these in the base level. I'll just comment it out for now. Okay, so prefix is going to be our desk directory by default. Then we have the bin directory is going to be where we want to install our binary that we create. Sbin is where we put our init currently. So now a section here to compile any C files. And run our compiler, our flags, and this tells it to redirect the output. And we're going to want to do the same thing for assembly files. So we'll just change this to _s and .s. Alright, so now we want to make a section for our make install, and we're just going to do a simple thing here. We're going to copy the target to the bin directory, and we'll do a clean one as well. Again, just oversimplified version, we're just going to use rm, remove object files in the target. Alright, so now let's start a makefile for our init program. So we're going to start off here by creating a target, and that's going to be the binary, so target equals init. Load our C sources. We're just going to use echo star.c. So this will collect all of our source files, and our objects are going to be made up of the C sources .c equals _c.o. Alright, and so for all, we're going to have the target And we'll just start the target section here. And that's going to rely on the objects. So now we'll just set up the compiler section we call CC, put our LD flags -O, and our target and objects are the ones that it's going to put in there. And we're going to include that base.makefile. So let's go in here to our init function, and actually under mylib we'll start by creating some source files in there. We'll start with a makefile, and we're going to use a sys.c. That's where we'll put our system calls. And let's say util.c for any utility methods, and start.s. We're going to try to move all this stuff in here into the library here, so we can avoid using assembly code inside of our main programs and just have it in the shared library. We'll put the start in there too, and we're just going to call main from that, just like we did before. So this one we can actually just delete. We don't need it anymore. Let's go to our include. Let's see, we'll want to create a include file so that we can get a little trouble here with the IDE. Oh, there we go. Alright, so we'll create an include file here. We'll call it mylib.h. So this is going to have any of the exports that we want to export from our library and use in our other programs. We can just take all these things here. We'll take those two, put them in sys. Or those are, maybe they're utility methods. Let's go here and copy that. We'll put that in our lib.h. We want to use extern, and we'll use pragma once at the top. Alright, let's go back to our utility functions here. Take these out of there, and we're going to put them in our source file here. Alright, so we're going to include the syscall.h like we had to before, so that'll fix those issues. We're also going to include mylib.h, and it's not finding it. It's actually, I can fix that in the IDE. We can just go to, see the extensions section here. If you want to do this in your own IDE, you can too, but I'm in Visual Studio Code. On this extension, I can just look up the include paths and add an include path. Looks like I already have source include. I'll just add a full path to that. mnt myos source include. Let's see if that gets rid of that error. Nope, that's not the right file. And let's go back to sys.c. Yeah, and there we go. It's cleared out. Okay, so don't think I like the names of these. Actually, these are, we can paste these in here. We'll rename them later. I'm just going to paste them in here so I can change these all to the definitions so we can export them. Use extern, we'll just put that in front of each. might group these together. They belong together. Let's rename these now. I'll call this one sysopen, this one sysread. This one I'll just call strlen and strprint. It's not that you need to. I just think it makes it a little more organized. All right, change it in the source file here too. Print. Alright, so now we have, let's take these and put those in. Oh, actually we're already in sys. Take this include and put it into util. Take these utility methods out of sys and put them in util, so we have them more separated here. Now we also need to include syscall here. There we go. And I found this error here. You need to remove that question mark, didn't belong there. So let's start on the makefile here for the lib. Alright, so we're going to start with our LD flags. We're going to use -shared, so that'll create a shared library that's loadable in Linux. Our target name is libmy.so. And we'll get all the C files. Create a thing here for the S files as well. Now we'll load our objects from the C sources. C.o. And same thing from the S sources, but plus equals S, S, and S. Alright, so now our bin directory for this one's different. So we're going to use /lib, so this will install our library in our OS's /lib folder. Create our target section. Okay, so now we'll use LD with flags here. LD flags. Our output is going to be target and the objects. And we need to include our base file as well. Okay, let me see, is that everything here? Let's open up a terminal, go to the mylib folder, and run make. A bunch of warnings it looks like. Let's take a look. We can get rid of these just so we don't lose errors in all these. Okay, just want to cast some things here. Use void pointer long and cast this FD, and we'll cast that size too. Anything in here? I don't think we need. Yeah, we already did our casting in that file. Okay. And looks like we missed strlen. There we go. Change that to stir_len. I think that's all the warnings we got. So let's make clean, clear, and make. There we go. So if we look here, we have libmy.so. So that's our Linux binary there. So shared objects. And if we do make install, we can see we put it into our mount myos /lib folder. Alright. let's go over here to our init makefile, and we need our LD flags for that one too, so let's set that. We want to link with my, so dash L for the library, and my is the library name, and dash uppercase L, we want to use myos path /lib, so that's where it's going to search for the library path. So, and binder is sbin for installing. And now let's fix this source file. First we gotta include our mylib.h. And now we need to rename these functions. Delay is okay. Print string we change to stir print. Print string, let's change all these. Then just our sys functions here. Let's see. Yeah, delay. Okay, open file is now sys open. Read file is now sys read. We can keep the rest as is. So let's change to the init folder and run make there. Okay, so let's look. We have our binary init there. So we can take a look with LDD and see what it links in. And looks like it's linking in more than we want it to. We have libc in here, which we don't want. So that shouldn't have been linked in. We need to fix that. Let's take a look at our makefile. Okay, LD flags our target. It's in our base. We have no std lib here. And we have the flags set in our cc command. Okay, I figured out what it was here. So I just forgot to include flags there in my init makefile. So now notice when I build we get this _start is not found, which we fixed before by putting our start in there. The problem is you can't export this from a shared library. So we're going to use a little bit of a hack, which is what GCC normally does when you use the C library. So we're going to create a crt0.s file, and we're just going to paste that in with our init function. So let's go into our makefile. We want to use this, look up the .s files. I'm going to put that in my init's makefile here. So I'm just doing this one thing real quick here so I can generate the crt0_s.o file. So that's going to have the code to start and call main. So I'm just going to copy that object file. I'll just put it in the root here. So, and what I'm going to do is in all the places where we do our linking, we're just going to, I can remove these here because we don't need them anymore. So all the places we do our linking, we're just going to manually add that crt0s.o, so we don't have to add an assembly.s file for each of our binaries. So I can put that right here in the base makefile. I can just say objects plus equals ... crt0_s.o. So now everything that I build is going to get that added to it. Alright, so now if I make, you can see here it included that crt0. LDD again. Now good, we only see my library, libmy.so, and this here is just a part of Linux, so it's not anything you need to worry about adding to your lib folder. So next I want to look at a couple of more syscalls, so we can integrate with some more system calls here. I'll bring Firefox back up. And we'll go back to that same syscalls table that we looked at last time. I can just restore session. There we go. Alright, so here's our syscalls table. And let's scroll down here. And I'll just Control F, reboot. Alright, so let's look at this reboot system call. So maybe at the end we'll just automatically reboot. So it takes a few different parameters. We're going to look at the manual page for it. You can see reboot takes, it's in this Linux reboot, here we go, magic 2, and command and an argument. So magic needs to be this value right here, reboot magic 1, which is FEE1 DEAD. And magic 2 can be any of these values here depending on the kernel version, but our kernel version can use any of them. And the command, we're going to want to use a specific one here. Yeah, Linux reboot command restart, so that value is what we're going to use for it. And we don't really need to use the argument value, we can just pass 0. So let's create a new function, unsigned long sys reboot. And we don't need to pass anything to this function, we'll just do it all inside the syscall. Return syscall sys reboot. And so the first value, let's just copy it from this manual page. Cast it to void. Stop annoying the compiler. Let's grab our second value. Just pick any of these, I'll take the first one. And for the last value, scroll down here. There you go. Paste that one. And we can just use 0 for the rest. So now when we call this sys reboot, it's going to cause our system to reboot. So let's export that. Let's go to another one. We'll create a better delay function. If we scroll here, I'll do find nano sleep. There you go. So nano sleep is a system call that you can use for sleeping a specified number of nanoseconds or seconds. So it takes these two construct time specs that are in time.h, and here's what it looks like. You have your seconds and your nanoseconds. So we can just take those and put them in our own function. I'm just going to copy time.h. We'll want to include that down in our syscalls file. Yeah, first we'll create our unsigned long sys underscore nano sleep. And the parameters it took, let's just paste this up here first, and we'll go back and copy those parameters from the manual. Just copy them both. The first one's the only one you need. The second one can be null. Let's see, syscall sys nano sleep. So pass in req, rem, and 0 for everything else. And we'll create a simpler function too, a utility function to invoke that, because nobody wants to create this struct just to sleep for a second. So we'll call it sleep sec, and int sec is the parameter. Let's see, then we'll just copy this type here. Oops, const tm. Actually, we don't want const. So we want to set our nsec to 0 and our sec to the sec value we passed in. So then we can just call sys nano sleep, pass in the address of tm, and null for the second parameter. Now let's export this. So we'll make it an extern in our header file. Let's go back to the mylib and make. Looks like some more warnings. Yeah, the REQ. It's using const qualifier. Okay. Yeah, we don't actually need const there. Just take that out. And that's probably the only issue. Yep, there we go. Alright, so let's make install. Put that in our lib folder. Let's go back to here and we'll replace these delays with sleep 1. Actually, it's sleep sec. Alright, find all the places we did that delay. One there too. And you know what, let's change this. We're going to, instead of looping forever, we're going to go from t to 0 to 3. We're going to do a couple of ticks here, and then right after that we're going to call sys reboot. So it should start up, print some data there, and reboot. So sudo make install. Everything looks good. So let's clear, and we can shut down. Actually, first let me show you something that I did here. I modified the boot grub config on the host machine, and I included our menu entry section right here to invoke the kernel using our root directory of our separate drive, and I have init sbin init. So I put it in the host's grub config, so we don't have to keep, we can just sudo reboot. We don't have to keep swapping the drive every time we shut down. So here we go. Here's it in our grub config. And Linux kernel is booting up, and myos initializing. We have ticks, and then reboot. So there we go. It rebooted. So I think that's a good stopping point for this video. So in our next video we're going to create another executable, which will be our initial shell environment. Then we'll use some more system calls to invoke that program. So if you enjoyed this video, please like, subscribe, comment if you have any questions. Let me know what other topics you want covered here, and I'll see what I can get to. So thanks again for watching.